Okay, this is day 2 of the foldable. So Katrina is going to get paid $5 an hour if she babysits. You're going to complete this table and you're going to find out how much she makes after 3 hours. Determine if it's linear or not, and we'll go over the definition of that. Then you're going to identify the rate of change, which is your M, and your y-intercept, which is your B, in the formula y equals mx plus b. So the y is going to stay, the equals sign is going to stay, your x stays, and your plus sign stays. You're just replacing this m and this b, and then we will finally graph it. So if she gets paid $5 an hour, I hope you understand that if she doesn't work at all, she doesn't get paid anything. After 1 hour, $5. 2 hours, she would then make $10, and 3 hours, $15. So we need to find the rate of change. Now you've already done this before. This is nothing new. We normally wrote the process in the middle before we graphed them. So what happens is you're looking for the change over here. How's this increasing? And this is all increasing by 5, while these are all increasing by 1. So your change in y divided by your change in x is 5 divided by the 1. 5 divided by 1. So yes, it is linear because it's a constant change. These are all increasing by 5, and those are all increasing by 1. So that is 5 divided by 1. It is linear because it has a rate of change is constant of 5. So your rate of change, you would then realize, is your m. That is your 5. Your 0 is your y-intercept. Remember, the most important one is that 0 stage. We've already been over these before. 0 stage, what's across from your 0 is a 0. So if we write it, again, your y and your equal sign stay. Your m is the 5. Your x stays and your plus sign stays, and your b is 0. So the true answer is just a plain old y equals 5x. You don't have to put the plus 0. Now we're going to go ahead and graph it. In order to graph it, you're going to use these dimensions over here. 0, 0 is that ordered pair. 1, 5, 2, 10, and then 3, 15. That's 4 different dots. Okay, so our y-intercept, as identified right here, is where we're starting on the y. So it tells us where it starts right along this y. So it starts at 0. So that means I have one of these, and you're drawing your dot at the 0. So go ahead and put a dot at your 0. Right at the bullseye. Okay, now the next one tells you the rate of change, meaning how it's increasing. So it's increasing 5. That's where you get the over 1 up 5 from. And you put the dot at 1, 5. That's where this is identified, 1, 5. Now for the 2, 10, meaning all I did was go over 1 more and up 5. So it's still the same technique. Up 5, over 1. Same thing. If I continue that process, I have another one, and I need to have it at 5 more up and over 1. So take it and go 5 up and over 1. And that's where that 315 comes from. The 315 is from your table. So really all you have to do is take these 4 and graph them, and it comes up with this. Your y-intercept was here, up 5 over 1, up 5 over 1, up 5 over 1. And that's where these ordered pairs come from. Another thing that you need to recognize right away is that it is increasing. It's going up to the right, so that's why it is a positive slope. This rate of change is positive. It's the angle of that line. So that rate of change is a positive 5, so it goes up to the right.
I didn't realize they're from here to one. Not Christmas.
I'm checking my pencil.
I
Okay, so let's use our table right here and identify our pieces. First of all, our rate of change came from the difference in our y's divided by the difference in our x's, and you got that -2. And that is what we label as our rate of change. That's going to tell us the steepness of our line when we graph it. This +1, that comes from this 0, 1 right here. That is your y-intercept. So that is called, and we need to label it as your y-intercept. Okay, so now if we know that, you could figure out your y-intercept is where it's going to cross this line. It's where this dot goes along this line, and it is going to land at the +1 right there. So put a dot at the +1. The rate of change telling you how far it goes, and that will tell you it's going down 2 over 1 because it's a -2 over 1. A -2 over 1. Now, you could have also gotten that from just graphing these, because this is the same as a 1, -1 over 1, down 1. This 2, -3 over 2, down 3. And the 3, -5 over 3, down 5. So those are the same as if you were taking these basic ordered pairs and graphing them. This is just an easier way to do it because this tells you the slope, the accent or the angle of your line. So it tells you down 1, down 2 over 1, down 2 over 1. It's down because it's a -1. And again, this number just tells you where to start. So that's where you're starting on that y-intercept before you start traveling down over 1, down over 1. Now it's also very important to recognize that this line is going from the top left down to the bottom right. It's going down this way. So if I started at the top of the hill, I'm going down. What I mean by down is that is a negative number. So because it's a negative number, it goes down to the right side. Okay, this one we do the same as the last. We identify that rate of change. So we got a change of 2 because 3 minus 1 is 2. 7 minus 3, the difference between these two is a +4. And the difference between these is an 8. 2, 4, 8. So it's not the same as last time. This is increasing by 1. This is increasing by 1. And this is increasing by 1. So if you look at your change in y over change in x, these two become 2 over 1, while this set becomes 4 over 1, and this set is 8 over 1, and those are not equivalent. So that means it is not a linear function. The reason behind that is you need to list your rate of change is not constant, because it goes from a 2 over 1 to a 4 over 1 to an 8 over 1. That's from a 2 to a 4 to an 8. So it is not equivalent. And you could actually figure this out by the graph if you had the graph, because what happens is you get something that does not form a line. So when you graph it, you have your y-intercept of 0, 1. It's right at that 0, 1. And then 1, 3. 1, 3 over 1, up 3. And then you have a over 2, up 7. And then you have an over 3, up 15. In which case, you notice it's kind of a curve, so that is not a line, meaning a linear function, line. Okay, so if we graph this, there's two things we need to recognize right away. First off, there's nothing being added or subtracted in this equation, meaning my y-intercept is a 0. It's also identified in my table as 0, 0. So to graph it, I know the first easiest one to find is along this line will be on the 0, because it's 0, 0. Now the other ones you could graph, and you could recognize the next ordered pair is right here at 515. So I could go over 5 and up 15, and it's going to land right there. Now there is a big gap, so if I wanted to actually graph the next one, it's not going to be in my table or on my graph, because if I go over 10, up 30, it's going off. It's not going to be on the physical graph. So I am identifying my rate of change. My rate of change is the 3. That is 3 over, of course, that invisible 1 that doesn't have to be there. The top number tells you how far to go up and down. In this case, it's positive, so it is up. And the bottom number is always to the right. Always to the right. So I need to go up 3, right 1. So I graph it, and I go up 3 from this point, up 3 over 1. I could graph another one from that point, up 3 over 1. And from that point, up 3 over 1. Because my rate of change is 3, positive 3. So positive 3, right 1. And notice it is forming a straight line that is going to the increasing to the right, meaning it is a positive 3. Okay, so let's identify our parts. The y-intercept is this 3. That is a positive 3. So that means I could automatically start by putting 1 dot at the 3 on that y-axis. Now the other piece that you need to remember to do is your m, and which is your y, or your slope. That's a negative 1/2. Now the 2, remember, tells you to go right, and because this is a negative, that is down. So you start at where you left off, at your 3, and you go down 1, right 2. And then again, down 1, right 2. And even again, down 1, right 2, until you form that line. Okay, so this is a negative 1/2 right here. So that's why that is going down negative. And so you need to write negative slope.